Hello, welcome back to Radar Systems lecture. The topic of this lecture is conical scan. There are three methods to generate the error signal in tracking radar: is sequential lobing, conical scan, and monopulse. The second one is conical scan. In sequential lobing, we use we used to switch the antenna beams sequentially, which is a tough task. To overcome that task, what we did here is we used to rotate the antenna beam to the antenna beam. This is the target axis. A is the target axis and B is the rotation axis. And the beam axis is the center one, which is passing through the highest peak point of the beam. Beam axis is different, rotation axis is different, and the target axis is also different. The angular difference between the beam axis and the rotation axis is called as the squint angle. It's called the squint angle. Now, this antenna does not need to switch the antenna lobes. It requires only single lobe, which should be rotated on its own axis, rotation axis. The angle between the axis of rotation and the axis of the antenna is called the squint angle. Now, as the antenna is rotated, now the normal rotation speed is 30 revolutions per minute (rpm). That means one revolution in 2 seconds. Because the antenna is continuously rotating, the signal which leaves the antenna will be a modulated signal. Similarly, the echo signal will also be a modulated one. The echo signal will be modulated at a frequency equal to the rotation frequency of the beam. Now, the amplitude of echo signal modulation will depends upon the shape of the antenna pattern, the squint angle, and the angle between the target, line of sight, and rotation axis. Now, this point you can understand with the help of this diagram. For example, consider if your target is here between A and B, what will happen? The antenna, half of the pattern, half of this lobe power will be incident onto the target, rest of the half gone waste. Now, the echo power which is returned back to the antenna will be because of the half of the pattern, so it is relatively lesser than the target which was hit by the lobe exactly on its axis. So definitely one parameter will be the squint angle, Second one, the shape of the antenna lobe. If it is very broader like this, then much of the power will be scattering in all the unwanted directions rather than the target direction. So if it is very sharper than the diagram which is shown here, if it is very sharp and incident towards the target, then the echo power will be much larger. Now, if you read this point, you will understand the amplitude of the echo signal modulation depends upon the shape of the antenna pattern and the squint angle and the angle between the target line of sight and rotation axis. Now, the phase of the modulation depends upon the angle between the target and the rotation axis. Angle between target and the rotation axis decides the phase of the modulating signal, because the angle between the target and the rotation axis definitely will have its impact on the modulated signal. Now, the conical scan modulation is extracted from the echo signal and applied to the servo control mechanism, which is continuously positions the antenna on a target. If you see this diagram, you will clearly understand that this is the duplexer. duplexer is connected with two blocks. One is transmitter block and the other one is receiver block. This we have seen in the case of pulse radar. In the case of pulse radar, we have seen this type of arrangement which isolates the transmitter and receiver using a duplexer. Now the received signal will pass through the second detector and range gate error. The output of the range gate error is supplied to the error signal processing circuit. Now this error signal generates two kinds of error signals. One is elevation angle error, another one is the azimuth angle error. Elevation angle error rotates the antenna in vertical direction, whereas the azimuth angle rotates the antenna in the horizontal direction. Whereas these two antennas are serving the purpose of rotating the antenna in horizontal and vertical directions, whereas the other two antennas help the antenna rotate on its own axis to have a conical scan done. So this is the block diagram of the conical scan tracking radar. I hope you understood this topic. Uh, Thank you very much for patiently watching. Thank you.